Hello and welcome back to the channel. It's Mark from Powersonic and Apprentice 121. Is this the most intelligent and easiest to install electric vehicle charge point on the market? Let's find out. So first up, this is the ICS H7D. I think I got that right. Yes, I did. So this is a 7 kilowatt domestic EV charge point. It claims to be able to be installed within 30 minutes. We're going to find out on this area behind me here. We're going to run through the whole install, speak about exactly what this does and some of the unique features it has built in that actually help us as installers. So let's jump straight on with the video and find out exactly what those are. So straight out of the box, there are a couple of things that I really like about this charger already. One is it comes in a nice protective bag, so it's not going to get scratched or damaged while it's in transit inside the box. And also it comes with a statement of compliance. So this is something a lot of installers will need when they're fitting EV charge points, and lots of manufacturers do not provide this. So it's really good to see that ICS have put that in there, and it actually relates to the product itself and even states the version of software it's currently using. It also comes with a detailed instruction manual, and it talks about the RCD protection that's built into this product. And we'll have a look at that as we're installing it onto the wall. But those of you who watch my prior videos will know that there are some issues with certain EV charge points and the RCD technology they're using. So we'll get to that later on. Let's unpackage all this, set it up on the wall and see how easy it all comes together, and if I'm capable of doing all this within 30 minutes. So if you imagine for one moment that this timber OSB board was a masonry surface, it does come with a fixing template. So you can see that there, it's got all your markings that you need for the fixings. You simply would hold it onto the wall, use a spirit level and ensure you get those straight, and there's also a hole that marks for rear entry should you be needing it. We're not using rear entry on this one. We've got the OSB board to fix the item straight onto, and we've also got our supply circuit already down here waiting to go. So we'll get on with doing that in a minute. You do get a little box of bits and pieces that come with it. So it comes with the plugs and fixing screws. We've also got some ferrules for the end of some of the cables that you'll be terminating potentially into the charge point. And we'll cover all that as we move the install further along. So in the instruction manual, we can see the first thing we've got to do is to fasten this to the wall, and that involves opening up the front of the charger. If you see there, it's indicating the use of a special tool. Now that tool comes in this little box there. It's basically a plastic little key. You insert that into the back and it should release and push forward the front cover, as you've seen just happened there. So that's your front plastic cover is now detached, and you can pop that to a side nice and safe while you're carrying out the rest of the install. So you can see on the front of here we've got some posi head screws just to take off and gain access to the internals. So let's do that now. So these Armeg screwdrivers I'm using here at Apprentice 121 Academy, we've had them down here since we opened up and started using this space, are properly decent. These have been holding up really well to consistent use, and the thing that's really nice is the magnetism on there. It actually holds the screws really well, which when you're dealing with a number of fixings as this has, the last thing you want to be doing when you're working outside is dropping a screw down an open drain hole or into the gutter somewhere. So the fact you've got a magnetic screw tip on and screws that will stick to it is fantastic. And I've got to say huge thanks to ICS as well. They've supplied us with this charger for free to use at the Apprentice 121 Academy, and they've also supplied us with a battery storage and inverter system, which is going to come in a later video for us to use here and demonstrate to learners coming into this training facility, so they get some exposure and use of current and industry leading products. I'm really grateful. They're absolute superstars, so massive thank you to ICS. let's carry on because the clock's ticking and I've only got half an hour to get this on the wall and finished up. Okay, so if you can see that in there's a little communication cable that runs between the back PCB board and the front cover. So we need to detach that just so we can loosen this forward and allow access to the internals of the charge point. And we can see we've got our rear entry hole there that we would have used potentially with the mounting bracket, or if we was doing this internal to the OSB. In our case, it's all on the surface because we're trying to make this visual for learners coming in to understand where cables are going from. So we're going to use the bottom entry gland, run our cabling in and make some terminations. But first up, I need to get this screwed to the wall. So we've got these little rubber bungs to remove from the fixing holes so we can gain access to them. I'm just going to set them to a side because we can reinsert them later on. Now obviously this is an indoor environment, so they're perhaps not going to help in terms of waterproofing, but typically these are being installed outside, so we need to be able to ensure we maintain our IP rating and everything is going to go back smoothly. So this is the EV Ultra cable from ProCell. You can see it's got the Cat 6A cable in there, which has got our CT connections, for example, if you wanted to use it for that, or you can use it for a data connection into a charge point as well. We've got our line neutral and CPC conductors, all sleeved and insulated as needed, and then there's the fabric outer covering which wraps around these cables together, and then some string that runs through the cable with all of these to keep it a bit more rigid and allow a little bit of separation between everything inside the outer jacket. So let's get this pushed through into this charge point, and we'll talk about how these cables gland in through the course of doing that. So you'll have seen there, this involves a weatherproof gasket on the bottom that the cable pushes through with its inner cores and the outer insulation, and then there's a clamp on here which will hold on to the cable coming into the charge point. Now obviously I assume if you wanted you could remove this and use a gland of your own liking. It seems like it would accommodate a different type of glanding if you was wanting to put steel wire armour gland for example, and there is also another hole on this other side which can be knocked out as well to make use of. So there are some options in the way that this is glanded together, which is nice to see, and we'll have a look in the instruction manual as well, which talks about the way that these cables should be brought into here. For now I'm going to start dressing these away, and we'll get these terminated into the appropriate connection points and move along with the install. So you can see with the two separate parts of the ICS charger opened up, there is some key components within each section. So at this side we have the mains power coming in, and you can see there's some CT measurement going on, which will be to do with the load management and the pen fault detection. And then we've also got over on this side a LAN port, which will be for connecting a physical wired internet connection, I assume, and then also this USB Wi-Fi dongle there is what I'm assuming that's for. There's another USB port up here, and then the anti-tamper switch on the top up there, and then this ribbon cable that links the two together. Now there's some dip switches here where you can set the maximum current that the charger will allow, and based on the position you place those in, it will allow more or less current. I've got them all in the off position, which is the default for 32 amps. So all we really need to do at this stage is connect in the ribbon cable, put it all back together, and see if we've got some power once we've connected up the other end. So I've got the power off down here now and opened up this Proteus board. These are fantastic, by the way, if you are installing electric vehicle charge points. You cannot go wrong with a Proteus EV range. This is one of the base variants at the TPN level. Obviously we're on limited funds down here at Apprentice 1-to-1 Academy. So funds were tight, but the bang for your buck you get out of this and the configuration output it gives you, it is excellent value for money. So we've got the two 4-pole RCDs at the top there. Again, currently we've not got these connected, but there are plans for that in the future. They're there for a reason. And then we've got the spine board inside the main part of the distribution board, which is supplying some of the other equipment and booths down in this area. We've also taken our EV into this top RCBO here. Is it the top one? Yep, the top one over there. So we've now got that connected. I've run through the dead tests on the cable down to the charge point. They're all absolutely fine. So we can look to put this back together now, get some power on and see what's going on with our new ICS EV charge point. So I'll do that right now. So you can see we've now got power coming down to the charge point. We've got the blue light on the front, which is telling us that there is electrical energy down here, otherwise there would be no lights. There is a sequence of colour codes that these change to based on the state of the charge point as well. We'll talk a bit about that later on in the video. Now it does go on now to speak about setting up the charge point, and it has a few different connection modes. You can connect to it through Ethernet, Wi-Fi or Bluetooth. So with the Wi-Fi it's a case of finding the local area network for this charge point, and with the Bluetooth you need to be within 10 meters and using the ICS 2.0 Lite mobile app. That's the option I'm going to use in this application, so I'm going to try and do that now and get this all connected up. So you can see I've popped the app onto my phone now. I've paired with this charge point. I've had to do that off camera because of the serial numbers and the Wi-Fi codes and such. If we now click into this, you can see it's in an idle state. So this comes as default, where you would need the app to start and stop the charge cycle. You can, if you want, go into the settings and change that, so you can do it just from the buttons on the front and from popping a plug in. But if you want to leave it in this mode, you would simply press start now. It connects to the charge point, and then your charge cycle will begin. You can hear it doing that behind me now. So that's indicating that the charge is kicking in, and we can see on the TIS EV100, which is the EV test product that we use day to day, we're now indicating a live voltage on L1, so we know that the charge cycle has begun. In the display it shows you how much charging has gone on with this vehicle. So at the minute we've only had 20 seconds, there's no amps drawn, obviously because there's no vehicle taking load. But if we stop the charge cycle, you can hear the app recognises that and it shuts the charging off. So we now know that that has been stopped, and we can remove our plug and remove the vehicle from the parking bay. So we can also, as I showed, if we go into the settings, we can change this. So if you want to operate it just from the plug and the start button, see it's giving me a success on there now. So in theory, with the charge point plugged in, I should be able to push the button on the front and it will begin a charge cycle without needing to use the app. And you can see it's doing that now. We've got the red indicator on the front. I don't know how that's coming across on camera. And again, if we want to stop that, we can press the button and it will do so as well. So for those of you who regularly follow the channel, you will know I use the TI SMFT Pro Plus for all the EVSE testing. I'm not going to demonstrate on this video, but there is loads of prior ones with the full test sequence shown. So if you want, go and check those out. But this has all come out just fine. We've been able to simulate the RDD test, and also check for any issues with the installation as is required with an EV test. And this gives you a full printout of all of the results you've obtained. So you've got that proof that you carried out the test. You can record the serial numbers, the date, the time, and a full log and data of every single test that's needed. So you are fully covered with your certificate of conformity from the manufacturer and your full set of results from the test process. It's really important that we do that. Let's move on to the product and put it all back together and see what we think at the end. So now we've run through the test process, we're happy that everything is functioning and working. What do I actually think of this? I think it's a really good, easy solution at a single phase point of use. You've got loads of features baked in. So this is compliant with other payment mechanisms as well. So if you want to use the ICS system to collect and take payments, then there is that option. But also you can create accounts with somebody like Monta, and this will integrate with that, so you can charge people coming to use the feature at your place of work or whatever that may be, and make sure the cost of the energy that those people are using is covered, which is a nice feature. It is really simple to wire up and connect. I can't believe that it would take anybody longer than half an hour, subject to the circuit supplying it being in place from end to end, as was the case here. And to be honest, I could have probably done it that quickly, even if that wasn't the case in this situation. So it is really simple to wire and put into service. We do have those useful points of entry, both for the rear and coming in from the bottom. And again, being able to limit the output of this charge point with the dip switches inside allows for some elements of load control based on the circuits that you might be installing these bits of equipment into. Now, I will say one piece of equipment you do want to look after if you're going to be installing these on a regular basis and to keep hold of is this little tab. It is actually metal, I think. I thought it was plastic to start with, but it feels a bit more metally now I've looked at it closer up. So I'm going to keep that to a side in my toolbox, and then I know if I need to, we can reach over the back here and pop that front cover off quite easily. Now, the manual that comes with this is pretty thorough in the way it explains the work that needs to be done to install it, which, as we've established, is pretty straightforward. But it also does cover off some of the safety aspects that are important to us. It states that this device inside here meets the requirements for open detection and also for RCD detection as well. And if we go off onto the CEF website, as you can see I have done here on my phone, alongside the nice pictures of the products, it will tell you here that it does no earth rod required because of the PME, that it is OCPP 1.6J compatible, and that it has built-in load management with Wi-Fi and Bluetooth technology. Most importantly is this statement at the bottom here. Bring you in a bit closer so you can see that. But it says built-in residual current detection, 30 milliamp Type A to IEC 61008 and 6 milliamp DC DD to IEC 6295, which is interesting because that's telling us we don't necessarily need to fit an upfront RCD on these charge points. Obviously in this application I have done, because that's the setup we've got in place here at Apprentice 121 Academy. I could have used an MCB because our cabling is in containment and on the surface of the wall. Now obviously if you're running a circuit to a charge point that dictates it needs RCD protection, you can fit that as well, and it states it in the manual that if you're going to do so, make sure it's of Type A variety, so you know you've got the adequate protection in terms of the cable feeding the charge point. So there's even more useful information on the data sheet itself for this product. So you can see here that you can get it to work with RFID cards should you wish. So if you want to have that option, you can do that. So the plastic credit card type things you can wave on the front of the product to get it charging. You can also change the button on the front for a key switch as well. So you see it does automatic minor fault recovery. So that's if there's a pen fault, it will recover itself. And it has a manual reset for the RCD and earth faults, which is what we need. And you can see here that it's compatible with solar and battery storage, and we're going to demonstrate that down here at the Academy because, as I said, we've got our inverter and battery storage system, so we're going to show this integrating with that. So if we look on the next page here, this is telling us more about the protection measures. So it's got the pen fault, PMEF fault monitoring that's compliant with Reg 722.411.4.1, which is what we need. And also that the overcurrent protection in terms of the RCD, is type A RCD with a 6 milliamp RDC DD built in, which is what we need as well. And then again, we've got the socket termination is a type 2 socket, as is commonplace now with EV charge points. And we can see here on the next page on the data sheet, it re-emphasises that point here about the RCD. So it says it has got a 30 milliamp type A 61008 RCD equivalent in here. So it is manufactured to the standard that's required, and it's also got the 6 milliamp DC RDC DD device to IEC 62955, which is really useful to us as installers. And then again on the next page, it goes on to re-emphasise about the types of protection you might need to use in terms of the cable feeding down to the charge point, and also its operating temperature. So it's -30 to +50. It is IP55. It's a Mode 3 charger. It has dual band Wi-Fi, so it will do the 2.4 and 5G. It's app controllable, and loads of customization options in the way that that's set up. So a nice little data sheet there that's readily available for anyone who wants to go and check it out for more details on exactly what this charge point can do. So we can see now we've got this ready to use here at Apprentice 1-to-1 Academy, so people coming in can now practice their testing, rewire the circuit if they wish to get better understanding of how these things are connected up in terms of RCD protection for the cable types running down to the chargers, as we've discussed, and other such things. Massive thank you again to ICS for providing this to us for free of charge. Really grateful. And as I said, we've got a video coming soon once Darren Staniforth has released his video first, detailing the installation of ICS inverter and battery storage system. And later on, we're going to do some demonstrations of how this can tie in with that to utilise the solar and battery ahead of the grid energy and such things as that, which is very exciting. As always, we've used the TIS test instruments to demonstrate how you can identify this thing as entering a charge state, but outside of that, I've run it through a full test process as normal and got the details and results of that stored in the instrument. And the fantastic Proteus distribution board that I'm using to power this, that is an absolutely incredible little board. We've got one at the main intake area here as well, and one down at these booths, just because of the versatility and options that it gives us in the way we're going to set up our final circuits and the protective devices that we can use in looking after them. So all in all, I think we've got a pretty good setup here now. So I think these are a really good option for anybody who's looking at a single phase charge point. They look nice, they're easy to work on, simple to install. They have lots of features built in terms of user configuration and control, but also safety features that as electricians are going to help us out during the course of an installation. And they're not expensive. They're around £470 plus VAT from CEF, so they're well worth checking out if you've not looked at them before. There'll be a link in the description. This isn't a promotion where I get 10% back for myself for advertising it. There's nothing like that going on. It's just where you go off and buy these products. So please do have a look at below, go and check it out. Thank you for watching. If you've got any questions in and around this video, please do drop them in below. And until the next time, I'll see you then.